Let's try and understand some of the graphical representations of photoelectric current versus accelerating potential or retarding potential. Alright, now let's check out over here. Y-axis is photocurrent, the current that is generated, the current that is being generated and recorded over here. And this is accelerating potential, the potential that we are applying over here, the potential that we are applying here. So what we find that when accelerating potential keeps on increasing, we find that the current also keeps on increasing. All right, so when accelerating potential keeps on increasing, we find that this current also keeps on increasing. So that's what we find. But then we already saw that it does not remain, it does not keep on happening infinitely. So there's a level where it gets saturated. At that time, what we get is this saturation. Here what has been done? Here varieties of intensities have been tried. Alright, so now here it's mentioned that this intensity is greater than this intensity is greater than this intensity. So what we find is, now since this intensity is greater, so this is current, photocurrent. So if this intensity is greater, we get greater current. Alright, greater photocurrent. Alright, if this is the least, so we get lowest current. Alright, so we get highest current over here. So with intensity, which we already have seen, with intensity the photocurrent increases. Alright, now let's check out what happens when we reverse the terminal. So that reverse the terminal in the sense, when we saw this got saturated, we changed the terminal. What we did with the help of commutator, we changed the terminal. Alright, so earlier this was a negative, this was positive, then this became positive, this became negative with the help of commutator. Alright, now commutator helped us in changing the terminals. Alright, now so that is this part that we are observing. So what we observe is that as we now, this is retarding potential, what we are doing is we are keeping on increasing the potential. Don't have a feeling that this is -1, -2, -3. So -3 is the least and -1 is the highest value. No, negative sign means it just expresses reversing of terminal, and the value is the magnitude which we are interested in. So what do we find? We find, let's take this one. Now we take the lowest one, the lowest intensity. What we find is that as we keep on increasing the retarding potential, what we observe is the current keeps on decreasing, and at a particular point we find no current. So that potential is our stopping potential, that is for this. Then let's take the maximum one, highest intensity. When we, with the help of commutator, when we reverse the terminal, what do we observe here? We observe the same thing even here. We find that as potential we are increasing the retarding potential. Why we are calling it as retarding potential? Because it is stopping electron from passing through. Alright, so as we keep on increasing the retarding potential, we find that the photocurrent also keeps on decreasing, and again at a particular volt it stops the current from flowing in. So that is what is called as stopping potential. Now the interesting thing is that no matter whatever be the intensity, we find all those three experiments showed same stopping potential. Mind you, this is for photosensitive emitter, for same photosensitive emitter. It's not for different metals. All right, but when we take for different metals also we'll find the same story. All right, so this is, say this is for metal A. We'll find that stopping potential is here. Maybe for metal B we'll find stopping potential here, stopping potential to be here. But then with whatever intensities you try, that metal B would be showing stopping potential over here itself. So this is property of a metal. Alright, so stopping potential. So no matter you try further intensities also, they all also would be coming here for this metal. Alright, so it is inherent property of a metal, stopping potential. Fine.